Wild weather. It's part and parcel of life in Queensland, isn't it? We've had some major events in recent years with floods and cyclones. Peter Otto is a senior forecaster for the Bureau of Meteorology's Tropical Cyclone Warning and Regional Forecasting Centre. Peter thinks a lot about natural disasters. He's conducted 4 tropical cyclone post-event surveys, including a comprehensive look at Cyclone Larry, which crossed the far north Queensland coast back in 2006. He'll be presenting his findings on Larry at the annual meeting of the Asia-Oceania Geosciences Society in Brisbane tomorrow, the first time ever this meeting's been held in the Southern Hemisphere. Hello, Peter.
G'day, Fiona.
What's your fascination with cyclones?
I just wanted to understand it. I forecast these things, and I went, as you said, inspecting the area after the impact, and became pretty committed to providing some explanations to the community, but also very committed to trying to help us improve our disaster planning for the future. And that's a really important thing to try and get right. So, we need to understand how strong any event was, particularly this one, which was, the strongest in probably 3 generations, until Yasi anyway. And so these events, these critical high events, are used for community planning, to how many nails go on your roof, or how strong your walls are, and also how close your buildings go to the sea. And so it's really important to be clear on how strong it was, and also our uncertainty about that as well. You can't always measure the strongest winds in a tropical cyclone. They're pretty hard to measure at times. So, it's important to understand our certainty about that, or uncertainty about the strength as well.
And what were your key findings on Cyclone Larry?
Okay, well, Larry was quite a complex storm. Now, it's not unheard of for storms to be complex by any means, but this was a particularly complex one.
And what do you mean by complex when you're talking about a cyclone?
Fair question. Look, okay, well, a lot of people think cyclones are donut shaped, with a calm eye in the middle, and they're perfectly circular. Well, that's sort of the ideal state, but this particular cyclone had little waves, little pockets of different strengths around within the eye wall. It's kind of like imagine a bad bicycle wheel, sort of rotating around in a wonky way. Well, Cyclone Larry was a bit like that. It had, if you like, speed wobbles. It had these bits of turbulence on the edge of it that actually made the eye wall irregularly shaped. At times it was quite elongated, like a very long oval sort of shape, and at other times it had even hexagonal or pentagonal kind of configurations to the eye wall. It wasn't a circle. It wasn't a perfect circle by any means. And within little pockets of the eye wall, maybe 5-10 kilometres across, there was very heavy rainfall in parts of the eye wall, extremely heavy, even for the eye wall, and locally even more intense winds within the otherwise strong eye wall winds. So there's basically pockets within Larry that were quite a lot stronger than other parts of Larry.
And at the time, what did that mean in terms of, predicting where it would cross and what it would do?
Yeah, well, cyclones with this sort of behaviour, with these waves within it, can change in their intensity quite readily, and that certainly was the case with Larry. So it intensified very rapidly as it approached the coast, and then it really slowed down in its strength, and in fact it sort of tapered off at its strength in the last 12 hours before landfall. In fact, close to landfall, its eye wall almost completely collapsed, and then it re-intensified in the last 2-3 hours as it crossed the coast, before it crossed the coast. So, look, it was evolving in very unique ways as it moved towards the coast, and so it became a bit of a challenge for the forecasting. But I think really the most critical challenge with Larry is sort of in the post-event understanding of it, is just trying to understand, did we measure the strongest winds in this storm? And I suspect we didn't. So
what was the strongest wind that you did record?
Yeah, well, look, we got good corresponding radar evidence of strongest winds being probably on the beaches at Dingle Bay and Etty Bay. That's in the radar, but unfortunately there's no wind measurements beneath that. So that's a bit difficult to get a handle on the strongest winds underneath those sites, which we suspect the strongest winds are at. Elsewhere in the community, there's damage that engineers have inferred wind strengths from, with gusts estimated to be around 240, 250 kilometres per hour. So that puts it in the mid-category 4 standard, for those strengths. But we do believe that there's reasonable evidence of there possibly being stronger winds elsewhere.
I'm speaking with Peter Otto. He's a senior forecaster with Queensland's Bureau of Meteorology. And Peter, there was some, well, not controversy, that's the wrong word, but there was, was it a 4, was it a 5? There was a lot of argy-bargy around that, wasn't there?
Well, I think that's probably the sort of debate that happens with a lot of storms, really. It's quite a personal issue for some people, and certainly a very important one to get right for community planning in the future. And look, the truth is that it's always going to be a measure of uncertainty associated with any impact. Even in the United States, Hurricane Andrew in the early 90s now, that was a very, very intense storm, and there was debate about that. And they've got really incredible instrumentation and over that way. And basically, these storms are so structurally complex that it's really hard to get a perfect handle of the strength of a great many of them. So uncertainty is nothing new, really, and it's something we just need to understand. And one of the things we're really trying to advocate, I guess one thing I'll suggest in my talk tomorrow is that we just need to maybe document our level of uncertainty about the strength of any storm, and the assumptions we make to derive the strength we come up with, so that future generations can pull apart our work, and if they disagree with, they can actually know how to change our work. If we document all our assumptions, they can employ different ones and perhaps clean up our work and get a better sense of how strong these events were, so they can compare them to their events as they get them.
And possibly use that information to help predict or track future cyclones?
Well, I think, yes, the understanding we're developing about these storms with these complex structures will help future forecasting, certainly. And, computer modelers, they do amazing work. I mean, they really make us look good. I mean, they are just going ahead and leaps and bounds what they are capable of doing. And they've got computer simulations, I've seen them, of Larry, which does replicate some of these complexities within Larry, which is absolutely remarkable. So they're doing fantastic work, and they'll only get better. But I think one of the key things about this is just understanding how much we're sure about and what we're not sure about, so that we can be better equipped to plan our buildings and our community responses for future events. And I think that was one of the real strong motivations for me, was understanding it so we can make sure we're better prepared for future events. Thanks
for your time today, Peter.
Pleasure.
Peter Otto is a senior forecaster for the Bureau of Meteorology's Tropical Cyclone Warning and Regional Forecasting Centre. He's presenting his research tomorrow to a major gathering, the Asia-Oceania Geosciences Society. That's on in Brisbane tomorrow.